So we are going to just continue with yesterday's thing. We are going to start as something called conservation laws. Conservation laws might have studied in your earlier incarnations, in your earlier classes. That, the statement has been that the total energy is constant, whether kinetic potential or all the energy is included. So if there is any reconfiguration or any readjustment of particles in a given field, that will not alter our fundamental premise. The fundamental premise or assumption is that the total energy of the system is conserved. In your earlier classes, आपने पढ़ा होगा that for example, if kinetic energy it comes at the expense of potential energy and vice versa. If potential energy increased, अब kinetic and potential energy, you normally we have mechanical system, any other system. So we are this time involved this conservation law, these are mechanics. So now we have to see these conservation laws in the language of how we can formulate or how we can articulate or how we can state them within the Lagrangian formalism. But the thing is the same thing. How if the total energy of a system or total is conserved in general sense, since we have formulated mechanics in the Lagrangian way, where the equation of motion is not a physical dynamic. The equation of motion is dl by dt minus d by dt of dl by dx dot. So two parameters are velocity. So how we can formulate conservation laws within Lagrangian formalism in general mechanics. So this is our so if you see, for example, so what are our main building blocks and main identifications in Lagrangian mechanics? One is position, another is velocity. So taking these two things, so if it is represented by s coordinates, it's also represented by there are s variables which are going to be represented by, for example, since Cartesian coordinate we only say 3n, okay, x, y, z. Because the components can be more than 3, because they are components in composition. So we talk of S. Or, so if it's the S over, if you take this two S variables, then you will have 2S quantities. And S can vary in 1, 2, 3, it depends upon the problems in consideration or problems understanding. So I can vary from S. The thing is, there are some things which remain constant during the motion. For example, any motion you start, something remains constant. And those constants are known as what we call, if we represent them by some functions, they are known as integrals of motion. Just like if you I'll just take जो आपकी ये है, if you remember calculus की definition. Differentiation is the process of finding a derivative of a function. So integration, if you integrate a derivative of a function which is given, if you integrate it, you will get the function back, but plus some. So if derivative get some function, you can take derivative as some particle is moving dx by dt. You can take it that way. Got my point? If you want to have a so we are basically interested in what remains constant or what remains conserved if a state of a system goes from A to B. For example, if the in your earlier class kinetic energy of one potential energy 1 by 2, you go from state A to state B. 1 by 2 m1 x1 square goes to 1 by 2 m2 x2 square. mg h1 goes to mg h2. So 1 by 2 m1 x1 square plus mg h1 is equal to 1 by 2. This after the reconfiguration or rearrangement. So we are doing the same thing. So if you are going to have these two variables by which we can associate our Lagrangian dynamics, what are the constants or integrals of the motion, and how we can determine also that point. अब ये है कि if you have any linear equation, there is a way of solving a linear equation or any equation, that the number of variables must be less than the number of equations will be solved, easier हो जाता है solve करना, है ना? So in this case, for example, अगर हमारे पास we have two s quantities which correspond to s for position and s for velocity, they are to be determined. So there can be some redundant degrees of freedom. Redundant degrees of freedom हो गया, there are those degrees of freedom which don't count or which come out to be constant, है ना? For example, body starts from rest, so its value is u. When you take v minus u is equal to 80. So if it starts from rest, sometimes you say initial velocity का value क्या ले रहे हो? You take it 0, है ना? You take it 0. So in the same way, you can have a correspondence. You are going to integrate this equation. We can reduce by virtue of some initial conditions the value of those quantities which are associated with position and velocity. So if there are two s variables, we can reduce those degrees of freedom by some variable. Depends if we have a constant equation of motion. कैसे हम कर सकते हैं? For example, while we are if it starts from 3 plus t1 minus plus t1 plus जो subsequent so subsequent orders of integration होंगे, you can subtract the initial from the subsequent from the subsequent, and by this you can reduce 1 degree of motion. Okay, that's why you can do this. For example, qi can be written as the same way qi dot and these functions are called integrals of अब इसमें है कि the notion of time is not involved explicitly, so you have to take into consideration what is known as explicit variable. The other is known as so implicit variable means that we said yesterday. हमने कल सिस्टम को अगर पहले हमने एक फ्री पार्टिकल लिया, फिर 2 पार्टिकल सिस्टम लिया, फिर 2 पार्टिकल सिस्टम को you first insulated with regard to environment, then we allowed them. But उसमें भी हमने जो वहाँ से वैल्यू आ रहा था उसका constant explicit dependence on time है या implicit dependence on time है. So if you take explicit dependence on time, then time is taken as a variable. Then time is taken as a time के साथ भी चीजें vary होती हैं. Things are varying with regard to. So if you take time as an implicit variable, that changes with quantity. You got my point? So the notion of implicit and explicit time here. जो integrations of ये है ना, how can reduce from 2s to 2x minus 1. We can do it only when we have a particular understanding of time. Okay? Then we can reduce this 1 degree of freedom. Got my point? So this is 1. Now, the important point is basically when I started previous class, I talked of two things: isotropy and homogeneity of time. So, time as a variable, how we can pin down time as a quantity, as a variable. So, aside that, every point in space has its own same value of time. If you take it that way, this understanding helps us to any system goes from state A to state B. In a given state, it has its own position coordinates and its own velocity coordinates. It is going to system B from Q to Q dot. So what are the integrals of motions and what are the constants of the motions? What are the integrals of motions and what are the constants of the motion? So if we have a homogeneous motion of time, homogeneous motion of time means the value of time will not change from point to point. What my point? So having this understanding, we can calculate these integrals of motions, the constants of motion. Stop covering if you just study df by dx, just like I just said, md2 by dx square is, I just said it. One time integrate it, will get but plus c1. Again integrate it, will get displacement. But it will be c1 plus c2. So these you can take as integrals of motion. But if the body has started from velocity c is going to 0, origin, so a variable has reduced. Got my point? So in the same way, here we are taking the analogy here. We are taking coordinates rho and q dot. And since the variables are not 3 like Cartesian coordinates, there can be n variables or there can be n components. And they are not necessarily 3n. That's what we are taking S. So how can, if the notion of homogeneity of time is taken, and time is taken to be as a property which we have used previously also, something called additivity. So make additivity. One is homogeneity of space and time. The another is and the quantities are integrals are said to be conserved. Integrals are said to be and the property of additivity. There is a function x and f is equal to f1 plus f of so if you multiply it by a, for example, so a can be multiplied by f1 plus. So if a system is composed of two subsystems, so there is some constant property which is the property of the whole system. You can say that if you reconfigure that closed system, आप system को isolate करेंगे, you make it partitioned into two parts. तो एक part की कुछ velocity है, there is some velocity or some positions are associated with the subsystem, and system B has some position and some velocity or some description of Lagrangian is there, and there are these equations of motions. You are going to calculate the Lagrangian before they are going to interact. Now you allow them to interact. Allow them to interact means the particles go from here to there, here to there, here to there. So you should be able to get back this property. The integrals are to be. So, and you should be able to get, say that the system is conserved. इसमें there is another certain point आपने सुना होगा, the whole is made up of parts, but it's not always true. So if these three assumptions are correct, you have to think about it. Whole is made of parts. Okay. But once you इसको आप dissect करोगे ना, can parts add to whole? If the system is conserved, the parts will add to whole. If the system is not conserved, the parts will not add to whole. There will be dissipation energy which we cannot account for, or dissipation. The system will not be conserved. The integrals of जो हम calculate करेंगे regarding these positions and momentums, so we cannot. There will be some missing parameters. So in principle, we can start from conserved system or we can start from nature में कुछ भी हो सकता है. But conserved system key properties, if you have homogeneity of time, isotropy of space, and this additivity property, you can say that the system has these. We can derive conservation laws in the Lagrangian. In your earlier classes, you have studied conservation laws in different ways. Kinetic and potential energy will conserve. अगर kinetic ज़्यादा होगी, it will convert to potential energy, vice versa. But now you are formulating this mechanics understanding in the Lagrangian way. Lagrangian way में हमारे पास these two parameters, and जो हमारी differential equation है Lagrangian dynamics, which has been arrived from we can have this way of expressing or articulating our conservation laws. Okay. Now comes this definition of अब ये है the explicit and implicit dependence on time. Explicit, for example, this is implicit dependence on time. Help me just see. Implicit means this is dq. This is qi dot. आएगा ना dq by dt. q कट जाएगा, then it will be dl by dt. इसी तरह dl by dq dot, q double dot. इसका dq by dt ऊपर जाएगा, dq d double q dot पर एक आएगा dq dot, वो कट जाएगा. So the notion of time is implicit in it. If you want to, अगर आप where you see equations में how we can represent implicit and अगर explicit dependence of time होगा, तो we can represent it by simplify this. So Lagrangian is dependent directly on time. Here Lagrangian is dependent upon time, not directly, but indirectly. dl by dq dot, basically it is dependent upon velocity. Position is dependent upon time. There is a quantity called velocity. So Lagrangian of you are taking this derivative with regard to a sort of velocity, right? Not time directly as a parameter. Indirectly you are taking time, not directly. So if it is taken directly, so this, if you take notion of time as an implicit variable or as an explicit variable, इससे क्या फर्क पड़ता है? ठीक है? Implicit कोई होगा ना, कोई closed system में particles are there, they are moving as such. But if you take time as an explicit parameter, so it changes things for us, or it should see what does it mean. So here, अगर आप बुक में जाओगे, here used just say Lagrangian of a closed system. So using this sentence, it's an important sentence. Lagrangian of a closed system does not depend explicitly on time. Okay, so this one thing. So Lagrangian of a closed system. So I just closed system means it's insulated from outside. जैसे कल हमने किया था सिस्टम को समटाइम्स बाहर से भी बुलाया, फिर हमने वो explicit dependence of, if you remember, explicit dependence of L Q Q dot, उसको हमने we just suppressed. So here comes the reason why you suppress that by that logic. Otherwise, it will lead to contradictions. Okay. The conservativity and other things वो आप देखना कैसे violate होती है या the system will not remain the way it has to be defined for our purpose. हाँ, so अब ये है कि we can how the Lagrangian change vis-a-vis time. Lagrangian means किसी भी system का Lagrangian कैसे change time. We can write it like तो जो हमारी जो अपनी Lagrangian equation है, it's like this: dl by dt minus d by dt of dl by dx dot. इसको हम कांस्टेंट so हमारी जो Lagrangian है, so अगर हमारा सिस्टम क्लोज्ड है, which is the way we have defined it, so this term will not contribute, will not take this. तो हमारी जो Lagrangian है, so it will be like, so it will not be, we have not to take this. So it's a closed system. तो closed system में we have not an explicit dependence on time, we have an implicit dependence on time. So we will use these two equations. We are going to use implicit dependence on time for the particles, the configuration of particles which we are interested in. तो हमारी जो equations of motion है, how they will span out or how they will come out to be. So it will come out to be like this. So again, so dl by dt will come out to be sigma d by dt of. So you have this is this. Now you put dl by dt इसका dl by इसका एक बार और आएगा ना dl by dt इसका भी एक और बार आएगा dl by. तो क्यों आई डॉट को बाहर रखेंगे d by dt of this, d by dt of this, and second term will be dl by dt. तो q डबल डॉट आएगा, q डॉट, तो ये q डॉट है, तो ये q डबल डॉट है. So now what we are going to do, we are going to थोड़ा सा reconfigure करेंगे. You can also write it as like this. You can also write it like sigma I. तो आप इसको देखो UV form में इसको देखिए. Write it in UV form, है ना? So you can see it. Can you write it? Q dot dl by q dot. देख सकते हैं कि नहीं? आप you see first time you differentiate q dot आएगा d by dt of this first term. This is अगर दो बार इसको differentiate करेंगे q double dot. कहने का मतलब ये है कि you can also write this thing in a simplified form. In UV form you can write it like this. ठीक है? But take this, we have not taken dl by dt. We have taken an implicit definition of time. So and formulated our system accordingly. तो हमारा जो Lagrangian है of the system, तो you can also write it as so now comes our now we are going to use this thing. We are taking the dl by dt. If dl by dt is 0, and now you are going to relate it with this equation, है ना? If dl by dt is, so we will only take this thing. Sorry. This is parallel वाला we have written this. So if it is this, so we can write it like ये तो 0 है ही है, dl by dt 0 है ही. If it is 0, if it is 0, इसको आप will subtract here. You can put d by dt of L minus या इसको यहाँ इसे Q dot dl by dq dot minus Lagrange is and again you are going to integrate. यहाँ से constant आएगा, ठीक है? So you can write it as you integrate it यहाँ से integrate करोगे यहाँ जाएगा ये constant आएगा. You can write it also. So E is equal to so here use the whole this representing this quantity by E. The book has used it like this. You can put quantity. So we can write the equation of motion to form. You can also write it like this. You can also write it like this. So it is called integral of the motion, and it is the total energy of the system. Total energy of the system, and it follows from the additivity property and homogeneity of time and implicit and explicit. Not the explicit dependence of time is not taken into consideration. अब इसमें थोड़ा सा ये है कि the implicit and explicit dependence of time. What do we mean by that? One is the value of time from point to point does not change. This is one thing. The another is time as a variable. For example, कोई quantity आ रही बाहर से, मतलब 1 मिनट में ये यहाँ से यहाँ तक चली, 2 मिनट में यहाँ से यहाँ तक चली, 3 मिनट में यहाँ से, so that is time as a variable. It has not to do with the time as a parameter. The time as a parameter may change from point to point. These are two different ideas. Okay? You have not to confuse this idea with that idea. From this idea is the second idea, where the value of time will remain same for every point. It follows from homogeneity of time. And जो मैं कह रहा हूँ time as a variable, so वहाँ ये आ रहा है. If you take a closed system, there is not any quantity which is dependent upon time as a variable. ठीक है? उस हिसाब से. You have to not confuse these two ideas. And mechanical energy systems whose energy is conservable are sometimes called conservative systems. इन्हीं को हम कहते हैं conservative. जिनकी energy we are called conservative. Class. The another way of writing this सिर्फ इसमें the way only difference is that जो हमारा Lagrangian है, so if you remember, it's dependent like this. The way we write this is the way we write Lagrangian. Its dependence upon position and velocity. Yes. Or if you have either homogeneous functions, इसको हम ऐसे लिख सकते हैं. You see it. dl by qi dot. ये है ना बेसिकली Lagrangian ये है dl. अगर हम इसको ऐसे लिखें 1 into mx dot square. d by dx dot. Differentiate it. It will be 2mx dot g. है ना? So this is what you can also write it like this. So since ये है mx dot है ये दो बार अगर डिफरेंशिएट आएगा mx डबल डॉट आएगा. So it will not be 1 into mx double dot. 2 are together. So you can also write it like this. Now another good first I'll just take 5 minutes or 10 minutes. Okay, the next start. So now, so this is this much of discussion. अब ये है कि how we can represent momentum. अब एक और चीज है, for example, there is some space. इस space में there are particles and positions and velocities. So now you are going to translate them in some space. You are going to make some displacement. X to x plus epsilon. ठीक है? तो इससे कोई फर्क पड़ेगा in the conserved system. तो if we have जो हमारी previous understanding है, we should not, there should not any, if we have some what actually translation by some epsilon amount, तो we should not, the system में कोई property fundamentally change नहीं आनी चाहिए. अब इसी बात को हम कैसे लिखेंगे? How we can write the same thing in the Lagrangian way? The way we have re-articulated our understanding of conservation system in the Lagrangian way. How we can say the conserved quantities को कैसे हम represent करेंगे और conservation and the laws को कैसे करेंगे? It's a Lagrangian way. So we have to do the same thing कि अगर we have translations in space and how we can represent quantities in the Lagrangian diagrams. So अगर हम change in Lagrangian eyes of what is the change in the Lagrangian? What is the change in the Lagrangian for infinitesimal displacement in space क्या है? Infinitesimal small change in Lagrangian. Delta R. dl by dr means small change in space. This is delta. This is not delta. You have to just differentiate it. This is infinitesimal. जैसे कोई quantity vary हो रही है किसी पैरामीटर के साथ. डेल्टा R कितना infinitesimal चल रहा है? पहले आपने उस quantity को vary किया है in space, but this is infinitesimal displacement. कितना वो चला? So this is an Euler theorem. कोई भी फंक्शन को हम पहले वैरी करेंगे, फिर उस वेरिएशन का हम इनफिनिटेसिमल कितना चल रहा है, दैट्स बेसिकली वी हैव टू डिफरेंशिएट डी फ्रॉम दिस. सो वही है इनफिनिटेसिमल डिस्प्लेसमेंट अगर हमारे पास वी कैन रिप्रेजेंट इट बाय एप्सिलॉन, वी कैन आल्सो राइट इट बाय दिस. So here the summation is over the particles of the system. Then since epsilon is the condition is that delta L will come out to be 0 is equivalent to so you can have if there is no change in the Lagrangian for infinitesimal displacement. तो we can say this and जो हमारी from Lagrange equations of motion so dl by dt so d by dt of dl by dt is equal to is constant और 0 भी आप कह सकते हैं और dl by dt अब यह है कि dl by dv को we can also write it as the another way of writing momentum. अब momentum को कैसे लिखते हैं, है ना? mx ये हो गया क्वेश्चन, mx डबल डॉट, है ना? हाँ mx हाँ momentum. So the another way of writing momentum is like this. So you write dl by dv by as we have dx dot. Lagrange क्या है? 1 by 2 mx double dot mx square minus b. If the configuration particles are constant position, but the derivative is dx dot, तो वो नहीं रहेगा. So you can, another way of writing momentum is like this. So wherever in Lagrangian way, how we want to get equivalence of momentum in the Lagrangian formulation, we write momentum like this.
Sir, 40 minutes is guys, sir. As I see,
2 minutes, I just get 2 minutes. 2 minutes. Or you can say that you can take the exercise you might have done.
yes, sir.
If two systems are conserved, you plus md1 by d2 plus md2 by d2 is equal to. So we have that exercise in earlier classes. We exercise for conserved closed system of. So I'll just keep it as how we can do it. But one thing I'll just stop at how we can write momentum. Momentum को हम ऐसे लिख सकते. So here there is difference between momentum and generalized momentum. The only difference between Lagrangian way of doing things is the momentum. Their classes is only 3 variables or 3 coordinates. Here this I is not necessarily 3. That depends upon the problem you are interested in. How we can set the Lagrangian and how we can maybe जो आपके ignorable coordinates हैं, ठीक है? How we can reduce them and how we can solve that Lagrangian differential equations. So you have in this definition of momentum only this I is generalized, and there can be rate of change of momentum is force. So the another way of writing is force is like this. So pi dot can also be represented as Fi. Now इसमें सिर्फ only one thing is that these are not normal forces, these are what? Generalized forces and generalized forces. Otherwise the equivalence or that broad holds. जो classical mechanics in your conventional classes and classical mechanics that we formulated as Lagrange. It has some advantages. You should be able to identify. हम एक formalism से दूसरे formalism में क्यों जाना पड़े? So once we are doing this way of stating this mechanics, इससे हमारे क्या फायदे हैं? What are the obvious advantages which are not there? That thing into consideration, then you study it.